This video focuses on solving logarithm equations. We'll be skipping this part, so please make sure you are familiar with them before you continue. So you can pause the video to familiarize yourself with the laws of logarithm. So we will now proceed to the main focus of this video, solving logarithmic equations for x. So as usual, I have compounded into different level of difficulty. So we'll first start with level 1 difficulty. So as you can see in this first equation here, as you can see, it's a logarithm function, but because there's nothing else that you can do, so you first convert it to exponential. So that's what I'm going to do it here. In this case, this is the base 2, so I just rewrite it in terms of exponential. So this is 2 to the power of 4 equals to x. Take note that the position changes, so please make sure you are familiar with how to convert. And as you can see, x is actually equals to 2 to the power of 4, so actually x is just simply equals to 16. So that's your answer. You can do the same thing for question 2, where there's nothing else that you can do. So same thing, just convert from logarithm to exponential. So usually for a logarithm function, we will deal with some algebra. So you need to do some manipulation. Hence, x is equals to 5. And that's your answer. Okay, so now we'll proceed on to question number 3. So notice that in this case, there isn't any bracket for x minus 5. Unlike the case where you see for question 4 where there will specify a bracket between x minus 1. So in this case, what does it mean is that you need to do some kind of algebra to rearrange the equation first. And from here, as usual, as what you see for question 1 and 2, I rearrange this from log to exponential. Hence, x is equals to 16. So that's my answer. Whereas for the case of question 4, again, we also need to do some kind of algebra because as you can see here, the plus 8 is not inside the bracket. So do algebra first, you minus 8 on both sides. And again, because of the negative 4 here, you need to first divide by negative 4 on both sides. Okay, so as you can see in this example here, you realize that the base is not shown. So for this case, you need to know that whenever they show a log a, it means there is a log 10a. It means that the base is a 10. So it's like an imaginary number so that you need to know. So hence this is a 10. So again, we just convert from log to exponential. X is equals to 1 over 100 plus 1. And that will be your answer. One last example for level 1 difficulty. So as you can see, in this case, it looks slightly different. There is not much algebra that can do. So what you realize is the left hand side has this log 2 and this right hand side has the log 2. So this is actually quite similar to what you do for exponential. Whenever they have the same base, you can just equal the power together for exponential. So same thing for this, since they have the same base 2. So you can just equal this to each other. Okay, so now we'll go on to level 2 difficulty. So it just looks more complicated. Sometimes you might have a power at the top where it's a log 4x to the power of 2. So one good trick that you can consider is you just bring the power down based on this property, where wherever you have a log a n to the power of b, this power here, you can just bring it down to the front. So it will be b times log a n. So similarly, I will do the same thing here. I just bring the 2 down. So this is 2 times log 4x equals to 3. And because in this case is a multiply sign, so you can just divide both sides by 2. So you get log 4x equals to 3 over 2. And hence, again, you just change this from log to exponential. Hence, x is equals to 8. So we can do the same thing for question 2. As you can see, the negative 3, we can just bring it to the front. Just divide both sides by negative 3. and now we just change it from log to exponentials. Let's go on to question number 3, where in this case you can realize that the base is x instead. So if there is no algebra that you need to do, you can just immediately from log, you just convert to exponential. In this case, you can see it's actually a quadratic. So what we can do is we can just simply square root both sides. But whenever you square root both sides, please remember to consider plus minus, even with one of the solution may not work. So this is hence just x equals to plus minus 3. Okay, so usually when you have two answers, you just always double check whether both answers work. For the case where base can only be positive, I will only consider positive base. So please make sure to reject the negative answer. So hence your final answer is only x equals to 3. So we'll do the same thing for question 4, where again we realize the base is x, so again just change from log to exponential without doing any algebra. So x is to the power of 3 over 2 equals to 8. Okay, so this one might seem more complicated because of the fraction. So in this case, instead of doing any square root, you want to get rid of the power 3 over 2. So how do we get rid is we just multiply by the power by 2 over 3, the reciprocal of it. So you just multiply both sides by 2 over 3, so that the power 3 over 2 will be cancelled out by 2 over 3. So the left hand side is x, and the right hand side is 8 to the power of 2 over 3. 8 to the power of 2 over 3 is actually just simply 4. So hence x is equals to 4. So that's your answer. Okay, so one last example for level 2 difficulty. So it's exactly the same thing, just in this case, first you just convert to exponential. So x squared equals to 6x minus 8. And because this is a quadratic, but you cannot just simply square root both sides, so you need to bring everything to the left hand side. And then you factorize or use your quadratic formula. You'll get x equals to 4 and x equals to 2. So in this case, as usual, whenever you have two solutions, please make sure to double check your answer. So how do we double check is we just substitute in to this, to your base x and to the 6x minus 8. So recall that log base something and something must be equal to something. So these two values here, the base and the one that is next to the base, both of this must be positive. So please double check. So you can just substitute in x equals to 4 and x equals to 2 into 6x minus 8 in order to double check whether you get a positive value, which in this case both is a positive value, so both answers work. So your final answer will just be x equals to 4 or x equals to 2. That's it. So now we'll proceed on to level 3 difficulty. So as you can see in this equation, it looks more and more complicated, where you see the left hand side is made up of two log terms. So what we do is we just combine the left hand side into a single log. So how do we do that is we make use of the log property. Wherever you see a plus sign, the number next to the base, the x and the 9, you just multiply them together. So since both sides is equals to log, has a log 2, so they have the same base, so I can just equal 9x equals to 5, so hence x is equals to 5 over 9, and that's my answer. Similarly, I can do the same thing for question 2, where I just combine the left hand side into a single log. So whenever you see a negative sign, you can just divide x over 7. And as usual, this has the same base, log 5. So x over 7 is equals to 2. So hence x is equals to 14. And that's my answer. Okay, so now we'll go to question number 3, So question number 3, again the left hand side, we just combine them into the single log. But in this case, the right hand side is not equals to log, so you cannot just simply equate. So what happens is, it's the same as how you do for level 1 and 2 question, you just change it to exponential. Question 4, again we just combine them. This is a minus sign, so this is log 2 over x equals to 1. So the right hand side is not a log, so we convert this into exponential. Okay, so now we'll proceed on to level 4 difficulty, where you can see the equation gets more and more complicated, but the only thing complicated is just that they add more algebra into it. So again, just combine the left hand side into a single log. So as you can see, this again, because both sides has log 3, so you can just equate them together. So hence x is equals to 3 or x equals to 1. Again, whenever you have two answers, please make sure to double check your solution. So how do we double check? You just sub it in into x plus 2, x minus 2 and 2x minus 1. Okay, so now we'll go on to question number 2 for level 4 difficulty. So as usual, because this one they actually make it more complicated, so what happens is you just bring all the logs to one side. In this case, again, you can just combine them into a single log. Because the right hand side is not a log, so we convert this from log to exponential first. Okay, so as you can see, this part, it looks very complicated, so make sure to expand it out first. You don't like fraction, so you bring the x plus 2 to the left hand side, so you just multiply both sides by x plus 2. As usual, please make sure to double check your solution by subbing into this and this, because they need to be positive. Okay, so for level 5 difficulty question, it might look very simple to you, but actually there's a trick to it, is that the base is actually different. So since they have a different base, you cannot just simply equate them together. So what happens is we need to make use of something called the change of base formula. So if you recall what's the change of base formula, log a b. If I want to change to a certain base, let's say c, then I need to use this formula, log c b over log c a, where the base a will be at the denominator instead. So this is a very useful formula for such question. So what happens is I want to change to the same base first. So what base should I change to? Of course, again, we just change to the lowest possible base. So in this case, you know that 4 is 2 square. So of course, we change to the lowest one, which is 2. So in other words, the left hand side, we just keep it to be the same thing, but we change the right hand side. So log 4x plus 6 is actually log 2. I want to change to the base 2. So log 2 x plus 6 whole thing over log 2 4. So we can actually simplify this further, otherwise it looks very messy. So once you get this step, you realize the denominator is divided by 2, so you just multiply 2 on both sides because of the 2 in front. So in order to compare log something equals to log something, make sure there's nothing in front or anything. So you bring the 2 back up as the power, so it'll be x squared log 2x plus 6, and finally now because they have the same base, so you can just equal them together. So hence x is 3 or x is negative 2. Then as usual, please substitute back into the equation to double check your answer. Okay, so now we proceed on to question number 2, where again, of the different bases, as you can see, here is 9, here is 3, and here is 3. But the right hand side, because both is 3, so you can just combine them into a single log first. So again, we just convert it to the lowest possible base. So in this case, the lowest possible is 3. So we convert the left hand side in terms of log 3. Then as usual, because of the too complicated looking, so you just simplify it further. And as usual, because of the denominator 2, so you just multiply both sides by 2. So then again, just bring the power to the back, which is just log 3 to x to the power of 2. And finally, we can just equate them because they are of the same base, log 3. And you just solve this algebraically. And make sure to double check your answer. So now for the third question of level 5. Again, because of the different bases, that's why you need to use the change of base formula. But in this case, there's nothing common between 3 or x. So nothing common. So what happens is you just convert it to either one of them. So I usually prefer a number for a base, so I just keep the left hand side log 3x. I convert this to the same base 3. So this one I just rewrite as 9 whole thing log 3 over log 3x, where the base that I want is 3. Then just further simplify this. This is 1 over log 3x, and the left hand side remains the same. So this one looks very complicated because of the log 3x. You cannot further simplify them. So we use the same technique as what we learned for exponential, substitution method. Unless you can see at first glance, then you don't have to use substitution. Otherwise, it's easier to use substitution. You see which one is repeated, log 3x is repeated, so you just let y equals to log 3x. So this is y equals to 9 over y, which is the same thing as 9 squared equals to 9. Again, because it's a quadratic, but you can just simply square root both sides. But whenever you square root both sides, please consider plus minus. So this is y equals to plus minus 3. And we are not done because we still need to find x. So log 3x is equals to y. So log 3x is equals to 3, or log 3x is equals to negative 3. Then we just solve them. So log 3x is actually just x equals to 3 to the power of 3, which is 27. And for the case of log 3x equals to negative 3 is actually log 3 to the power of negative 3, which is 1 over 27. So your final answer is 27 or 1 over 27. Again, just make sure you double check both of the answers by subbing it in. Okay, so we are finally at the last question for level 5 difficulty question. So in this case, it's the same thing as your question 3. First, you just convert into the same base. So again, I prefer 3 as my base. So again, because you don't really like log 3x, so you just let y be log 3x. So this is still not done. We need to find x. So log 3x is equals to 1, or log 3x is equals to negative 3. So hence x is equals to 3 to the power 1, so it's 3. And x is equals to 3 to the power negative 3, so it's 1 over 27. Then as usual, just make sure you double check. Thank you for watching, and I hope you understand everything.